Okay, guys, hello. We are still on the discussion on ACI direct design method and equivalent frame method. So this is part three of the series of videos I'll be giving you on two-way slab systems. So for the ACI direct design method and equivalent frame method, the manner on how to distribute the moments longitudinally is the main difference. Um, So to give you a basic discussion on how these two ACI procedures works, I'd like to first to show you how to visualize the system, the frame system that we are talking about in these two methods. So in these two methods, basically the frame system is created first now in such a manner that we can visualize now the parameters that we need to compute and check based on the criteria for limitations, etc. Before we can proceed. So considering this uh, slab system here, okay, it must be a multi-slab system composed of not less than three continuous span. Meaning, say if this is three continuous span, then the other direction here must also be three, no? Hindi lang napakita yung ibang span dito. But basically, this in this direction and this direction, the slab panels are at least three panels, no, for our limitations to be satisfied. Okay, so it doesn't matter where the L1 and L2 directions is, but uh, we have to bear in mind that we have to treat the analysis one direction at a time. Okay, so if we are looking into this direction as the longitudinal direction, it's better if we label it as L1, and this direction here will be the transverse direction labeled L2. Of course, if L1 has different dimensions, then we can put an L1A, L1B, L1C here to make some distinctions on the dimensions, and also with L2A, L2B, and L2C there. Okay? So for this particular example, we consider now our longitudinal direction in this direction. So this is now the longitudinal direction, and this is now the transverse direction. Okay, and the first thing we have to do is to consider the column strip that we want to analyze first. So in this case, it's very obvious that we make use of these interior columns here as your basis for the strip that we need to analyze as a frame. Okay, so this strip is measured at the center half span of your L2 and L2 in these two sides. Okay, so these are the center. Okay, so these are the center of your L2 here and the center of your L2 on the other side constitute your column strip. Okay, so this is now your sorry, not the column strip, but your frame strip. Okay, so this is now the frame strip. That's why it's called equivalent frame. So this is your frame strip, or which is half the center half of the bay L2 here and L2 at the other side. Okay, so we are referring to the strip. And in this strip, we have interior panels. Okay, so this is the shaded portion here is actually the interior panel. And this is still the interior panel. And somewhere at the edges here are your exterior panel. Okay, so if we consider your CD column bounding the interior panel, let's analyze what will be the moment, no? What will be the moment for this interior panel in terms of the longitudinal and the transverse direction. So if we make use of your um, uh, magnified panel here, one, two, three, four. So these are now uh, the basis for the parameters we need in order for us to compute, no? The static moments and other variables that we need for our procedure computation. Okay, of course, this panel here must be fully loaded as based on the limitations. So this WU is a factored floor load per unit area. This is the center line of your span. And the clear span is now measured not at 1, 2, but rather at 1, 2 prime. So this is now your Ln, which must be less than 0.65 of your L, okay, as given in your parameters. So for the moment diagram of your central panel, this is now the statics of a typical interior panel of the floor system. So you will notice that the longitudinal moments based on the static value is actually symmetrical because this is interior. Your negative moments here are just same, such that your M positive here is exactly at the mid span. Okay, so this is the center span of L1. If we are going to do some statical calculation, so this is simply equivalent to a WL square over A. Okay, so this is WUL2LN squared over. Okay, so that's how it is. That's how it works. Now, for the typical exterior panel, it will be a little bit skewed, no? So if you will take a look at the moment here, the maximum moment will no longer be at the midspan, but rather favoring the end span. Okay, so this is the end support I mean. So this is the end support or the exterior support, and this span here is called the end or exterior span. Okay, but if we only make use of some calculations which are approximate, then the static moment will be referred into the path m positively, not the n at the m max, which is simply the static moment mo. But take note that your m negative at the left and the m negative at the right are no longer the same, so we have to take the average value here for this. So this is the m average. Okay, so that's how it works. Now, on the ACI DDM method, direct design method, the distribution of these moments here are based on tables. Okay, so that makes the direct design method different from the ACI equivalent frame method. In the equivalent frame method, these are now based on analysis. Okay, so we have to analyze the moment based on the stiffness analysis. Okay, we're talking here of stiffnesses uh, that will be controlled and dictated by the end beams, the longitudinal beams, the slab, the columns, etc. So we have to compute those parameters before we can do the analysis. The good thing about the EFM is that the analysis can be made manually or you can use softwares. Okay, the analysis can be done using software. While in the ACI direct design method, because these are just tabulated values, then The values are based on approximate formulas or coefficients. Okay, so basically the difference lies on the determination and distribution of the longitudinal moment. So how will you distribute? How to distribute the static moment MO longitudinally is the difference, or it tells the difference between the ACI direct design method and the ACI equivalent pruning method. Okay, so on the next lecture, I will show you now how to distribute your ACI uh, longitudinal moments based on the tables that the ACI code gives us, and also how to distribute it transversely based on also the tables that the code, the ACI code gives us. And I'll see you on the next video to discuss or to continue this discussion. Thank you very much for listening.